All right, so going to number 31, same idea, except we will be using a cubed. So if I look at where that kind of vertex point went, it went, what is it, right 4, down 4. So when I start to fill this out, here goes my y. I'll have to figure out a. Whoops, that's not correct. Back it up. Okay, sorry. So it's going to be y equals a. I would have x minus 4 to make me move right 4, and then I would have minus 4 to make me move down 4. I'm going to need some other point, so that time this point has been marked here for you. So we will use 5, 0 as our additional point, xy. So it's going to go y equals a, 5 take away 4 cubed, and then minus 4. So another way we could have done this problem, 32 as well, is we could actually just add the 4 over first, which is what we did in most of the classes, and then I can just figure what this is so I can get a alone. So 5 take away 4 is 1, and 1 cubed is 1. And as it turns out, that is my a value. And so now what I can do is go with y equals a, and then finish the rest. A lot of 4's in this problem. So one quick reminder, sometimes you can find your a value really, really quick. Sometimes, not all the time. So let me erase this stuff. So the way you can find it really quick is if you go to where that 0, 0 point went, and you just move over 1, then how many do you move up, or maybe down? And then if you can get to a nice point, like I can here, I'm moving up 4, that can become my a value. That unfortunately does not happen over on problem 32, because when I go over 1, I can't go up a nice amount. I can go up, but it's some decimal amount that I can't see. All right, let's finish up with 33. So I'm going to get my equations first. I'm going to go to each line and figure out what m and b are. So this middle one is probably be the easiest. My b is 0. My slope is negative because it's going down. And so I just find a nice rise and run. And it looks like I'm rising 1 and running 2. So on the next one, if I just keep this going, I can see that my y-intercept is a -4, and there is no slope because it's a flat line. And then on this one, when I look at nice easy points, I can see my m is a 2 over 1, positive because it's going uphill. And then if I just continue that, let's see, up 2 over 1, up 2 over 1, I'll see that my y-intercept also happens to be 2. All right, so my first line is mx plus b, so 2x plus 2. My third line is mx plus b, so -1/2 x plus 0. And my third line is mx plus b. Now, if you want to leave the zeros out, those are things you can do, but I'm just sticking with the same format. So now I need to see, where do the lines start and stop? What are these walls? So my first line is to the left of -2. I think it's an open circle. Let's see. Yes, with an open circle, so I won't underline. My other one is between, so this is how we write between this -2 and 4. The 4 side will be underlined, and then the other one is to the right of the 4 line, and that one will not be underlined. All right, let's go into interpreting functions. So the most important thing we're going to do first is write down our important points. So -6, -4, and infinity, -infinity. So where it starts and stops, where it hits the x-axis, and anytime it turns, like a max and or min. Okay. First, I'm going to do my domain. So domain are the x stations, so from here to here, and I write my small x to my big X. The -6 is going to be parentheses because there is an open circle there. All right, for which values of x is my function f of x negative? So negative is going to be below the x-axis. So from here to here is one stretch, and then here to here is the next stretch. So this is where I just write my x values, -6, oops, and I left that point out. So let's get that written down. That was oh no, we got it. That's a -20, sorry. So -6 to -2. And the other one is from 6 to infinity. All right, for which values is it increasing? So increasing is going to be the green. So you're going to have two stretches from -6 to 0 and from 2 to 4. And then the next one is in the parentheses. So this is me telling you x. So I'm telling you to go left 6. And if you go left 6, there's nothing up. There is something down, but since it's an open circle, we should not include it. So this is actually a no solution. On my next one, this is saying y is 2. So if I go up to y is 2, I actually land on 2 points where x is 0 and x is 4. All right, let's do the next one. So again, marking my important points, starting, stopping, x-axis, and where it turns, so those mins and maxes. All right, my range. So my range is going to be my low y value to my upper y value. So that's going to give me a -1 and infinity. My end behavior. So end behavior we write like this. And then I want to know, what is my function doing? So on the left side, when my x is -infinity, my function is going up infinity. And on the right side, when my x is getting bigger, the function is also going up. Average rate of change, these are the x values. So if x is 0, I have a y value of 3. And if x is a 5, I have a y value of 0. So I put my sturdy glasses in the denominator, so 5 minus 0, the x values, which means I'll put their corresponding y values in the top. This will be an equal sign here. So I get -3 over 5, which I'm going to guess if this is multiple choice as far as the final goes, that it would be a decimal, so -0.6 over 1. Where is my function decreasing? So decreasing would be from here to here. So decreasing is going to go from -infinity to 4. Where's my function positive? So it's positive in two areas. Let's see, one is here. And then this little bit to the right. So I'll have from -infinity to 3. And then from 5 to infinity. The minimum is -1, and it occurred where x equals 4. All right, let's finish up this page and we'll get a new video. So just a reminder of what these initials all stand for. So in our first problem, we're going to go from standard form to factored form, which means I'm going to factor. So the first thing I'm looking for is a GCF. I do see one. There's a 3. I'm going to take it out. Let's not use a highlighter there. All right. And then this is actually more factorable. It's a difference of squares. It can turn into x plus 3 and x minus 3. So there is 37, its new equivalent form. All right, my next one, again, standard form to factored form. So I'm looking for a GCF. So I don't notice a number I can take out of all of these, but I can take an x out. So that GCF of an x is going to be down here, and it will be waiting for the rest of the factors. But when I take that x out, this is what I'm left with. So 3 terms, I'm going to use the x. So I need factors of -24 that make -10. You got to be really careful with 24 and 10. The correct factors will be 12, -12, and +2. So when I make my factors for this piece, x and x will not be enough to make 3x squared. I'll have to put a 3 in them. And now I can do these loops. And we'll have the 3x make the negative 12x with a negative 4. And we'll have the x make the 2x with the positive 2. And now I can just bring those factors to join my final answer. So all we're doing is factoring here. We're not solving in this section. So the next one is standard form to vertex form. So that's where we separate these x's out, and whatever that front number is exactly what we take out. So I'm going to divide both of these by a negative 4, which leaves me with an x squared minus 2x, and then I add the box, and then I minus the box. So I take negative 2, cut it in half, squaring negative 1 times negative 1 is 1. That goes here. And then I bunny hop, and that means I'll have a negative 4 here. So when I write my final answer, negative 4, in front of this parentheses will be what's in front of this parentheses, so a minus 1. And then 3 take away a negative 4 is a positive 7. All right, that is that page. Yeah, let's see how much more we can get from this page, just getting this whole idea done. So the next one is standard form to vertex form. So again, this is the box. I'm going to take a 1 out here, which doesn't change anything. So I'm going to take negative 12, cut it in half for negative 6. Negative 6 squared, negative 6 times negative 6 is a 36. Bunny hopping. Still have a 36 in the box. So now I'm going to have 1 with x minus 6, because that's what's in front of the squared. And then 28, take away 36, is just a negative 8, so minus 8. All right, let's get through these two and then we'll end this video. So our next one is from standard form to factored form. So again, anytime I factor, I look for a GCF. I don't see one. So if I make my x, what are factors of 6 that make negative 7? And that would be a negative 1 and a negative 6. So here come my factors. X and x are enough to make x squared. So one loop can make the negative 1x, so we'll have this loop make the negative 1x with the negative 1, and then my bottom loop can make the negative 6x with the negative 6. And then I'm done. I'm not solving, I'm just factoring. All right, last one, vertex form to standard form. Standard form has no parentheses, so we have to remember that there are 2 of these x minus 3's. I will take a moment and have these neighbors meet. So I'm going to get an x squared minus a 3x. And then the other neighbors start to meet, and I get another negative 3x with a positive 9. Can combine my like terms. I'll bring the 5 down. So when I'm done, my final answer is x squared minus 6x plus 14. And this will end that video.